Good morning to all. This is Divya. I am working as a assistant professor in Vailtech Multitech Dr. Rangarajan, Dr. Sakuntala Engineering College from the ADS department. Today we are discussed about the topic for UML. UML stands for Unified Modeling Language. Unified refers to the fact of the UML integrates and standards various approaches to modeling a software systems. So UML is not a programming language. It is a generic development modeling. So first we have to analyze design and implementations of the software systems. When we are software engineering, so first of all we have to design the document and then go through the coding part and then go through the implementations part we have used to the software engineering. So these methods are used to graphical representations and then pictorial representations and then communications to the people along with the softwares along with the software communications. So the objects management group is adapted to the unified modeling language. It's introduced by 1997. They have approval into the standardized in 2005. So UML has been revised over the years and reviewed periodically. So this is a history of a UML. So in 1980s, many different methodologies were developed to a model object-oriented systems, each with its own notations and approaches. Some of the most process we are Boch methodologies they have introduced. This is developed by the Greedy Boch, and then we have introduced the object modeling technique. This is introduced by James, and then OOSE. So object oriented software engineering. They are they have combined with the object modeling and then designs. So in UML 0.8 is introduced by in 1997. They have approved into the standardizations. So they have used to the object oriented analysis and design concept. They have used to the UML diagrams. While using a UML is commonly associated with a software development, it is called in various fields like remodeling and system engineering and teachings. They have involved into the UMLs. So when we are used for the UMLs, the approach is used for both methodologies. This approach is used for improvement a software process. There are two types of improvement a software process. First one is a micro development process and then macro development process. Macro development process means they have identified the classes, identify the semantic of your classes, identify the relationship of your classes and objects, and interface the implementations. This is the methods we have used into the micro development process. This is the daily activities of the process, and then small project software development team that can be used for this micro development process. Micro development process means it's a conceptual view of a UML. What is meant by conceptual? Conceptual means that is a there are three major they have involved. First one is a basic building blocks and then rules and then common mechanism. So basic building block means it's nothing about the UML things relationship and then diagrams. What is mean by things? Things means it's a structural things and then behavior things. Behavior things. So structures mean it's a static view. The behavior things mean it is a dynamic view. So structured things they have to follow the models in static element. So behavior things means they are follow the verb of the UML models. It's representing a dynamic behavior of the things. So it is a process executed by the developers that develops the software product. So when we introduce a those methodologies, it is used to improvement the software process. So EML is not different from the other common programming language such as a C++, Java, and then Copal. So EML is a pictorial language is used to make a software of the blueprints of your objects. So for examples, if you have constructed a new house, mean definitely you need the blueprint of your objects. So in software, people also they will start the new projects. Mean definitely they have need a blueprint of the software. So what are the requirements and then what are the design will be there, and then they will refer and then implementations of the software applications. So this is involved into the EML. So EML as since 1990s, there are objects oriented programming methods also developed in 1980s and earlier to 1990s. It is originally based on the notations of the Voch methods and then object modeling technique and then object oriented software engineering, which it is as integrated into a single language. So what is a system? So a set of elements is organized to certain objective from a systems are divided into the subsystem are described by a models. That is the systems. Model means it's a simplify the complete and constant abstractions of a system. So view means it's a view projections of the system models. That is a unified modeling language. So unified modeling language is a visually that helps to the developers also. Types of EML. So EML diagram, there are two types: structural diagram and then behavior diagram. So what is the structural diagram? So structural diagram means it's a focus on the statistic aspect of a system, such as a components and relationship of the object. So they are involved into the class diagrams, object diagrams, component diagrams, deployment diagrams, package diagrams, composite structures diagrams, and then profile diagrams. This is our structural diagrams. So behavior diagrams. So behavior diagrams focuses on the dynamic aspect of the systems, such as the interactions of the activities of the diagrams. So it is a types of behavior diagrams as use case diagrams, sequence diagrams, activity diagrams, state machine diagrams, communication diagrams. So what is the difference between statics and dynamic views? So static views are automatically updated and related to the object. Structural diagrams. So structural diagrams or a visual design technique is used to show the step needed to solve a problem. So show the things in the model, the systems they have used into the classes and then object and then packages and then deployment of the object of the diagrams. Behavior UML diagram. So what is the behavior UML diagram? So UML diagrams is represent to the visualizer. So how the system behaves to interact with itself, with the users and other systems and other entities. Is focus on the interactions between your components and activities and states and messages, even and their interactions of the UML diagrams. Class diagrams. A class diagram is a set of static structure diagrams in unified modeling language that represent the structures of a system, showing its classes, attributes, methods, and the relationship between the classes. It's a key part of the object-oriented design and development, helping developers and system architects visualize the structures of the software. So, key elements of a class diagrams for class, first one class and then relationship and then visibility. So what is a class? So class is represented a rectangular shape. A class is divided into the three sections: The top section is contain the class name, the middle sections contain the attributes, the bottom sections contain the methods. So relationships. Relationship means between two classes where one class used to interact with the others. That is a relationships. So relationships we can use associations, multiplicity, inheritance, aggregations and compositions and dependency symbols we have used into the class diagrams. So third one is a visibility. Visibility defines the accessibility of a class, attributes and methods. So public, private and protected. So this is the examples for library management systems. So like here you have library management systems. Here mention the user type, username, password, and then again login, registers, and logout. So user actually they have maintained name, ID, verify, check account, and then book get your book information. So either the user may be staff or students. The account may be either the users they have aggregations into the class. So book, there are so many books available into the library. So first of all, title, author, ISBN, publications, and then we have give some. This is a book is a main class. This is a operations. This is a attributes. This is a overall class diagrams. So we have used to librarian. So here mention name, ID, password, search strings. This is a operations. So we have used into the attributes. It's a verify a librarian and search. So in library database will be there. So library database the maintain the books. So we have to add the books or delete the books and update the books and then display and search. This is the overall activity. This is a overall diagram for the library management systems. So next one is a use case diagram. So use case diagram is type of a unified modeling language diagram that represent the interactions between a actors and a systems. So use case diagram is a visual representations of a interactions between a users and a system to achieve a goal. It is typically includes actors, use case, system boundaries, relationships. So actors it's involved into the entities that interact with the systems such as a users or other systems. So use case. So specific functions or features that represented into the fulfill of your requirements. So next one is a system boundary. The system boundary is the scope of the systems represented by the rectangle enclosing the use cases. So relationships. So relationship means the actors and then use case they will collaborate with this. So lines connecting a actors to the use case which can show the association, generalizations or dependencies. So to create a use case diagram means the following the rules. First one, identify the actors. It determines who will interact with the systems. For examples, customers are either admins. So next one is to define the use cases. So let's list the tasks of the functionality the systems will provide examples, login or purchase item. Next one is draw a system boundaries. So outline the systems and place the use case inside it. And then last one is connect your actors to a use case. This is a use case diagram. So how many actors will be there and how many system will interact into the uh, real-time scenarios they have used. So this is a examples for use case diagrams for online shopping systems. So customers is only one involved. The system administrations there are so many are involved. So first one the customers. So first one the customers will view the items and then may view the items. The items will authentications and then we will provide the make a purchase. So identify the providers and then we will complete the checkout to the product will be available or not. So once you have to complete it checkout, they will payment of the process, the credit payment of the process. So the payment of the process is done means they have given the some options of the pay the money. So that we will pay the money and then we will log in and then we have check out the items. Sequence diagrams. It's a sequence diagram is a type of a interactions diagrams. Type of a interactions diagram. Diagrams. So sequence diagrams are involved into the how your objects interact into a particular scenario of a use case, showing the sequence of a message exchange. It's type of a interaction diagram used in UMLs. So here we have created and understood a sequence diagram. So first of all, participant. So participant means they have to object. To represent the object. It's represent the object. So objects are representing by a rectangle at the top of the diagrams. Those are the entities, object or actors involved in the interactions. So next one is a lifelines. Lifeline means the vertical dashed lines extending from each participant indicated the lifespan of the participant during the interactions. Next one, messages. So the horizontal arrows between the lifeline representing the communications between your object messages can be synchronized, requiring a responses are asynchronous. Next, fourth one is a activations bars. The activation bars is represented to the period of during the objects processing a message. So last one is return message. So return message means the dotted line showing the response from one object to another. Next one, conditions and loops. The notations represent the conditional logics or loops. So steps to how to create a sequence diagrams. First one, identify the scenario and then determine the participant, define the messages, draw the lifelines, add the message, include the conditions and loops that will be followed to the sequence diagrams. So sequence diagrams are sometimes known as a event diagrams or event scenarios. This diagrams is used to help the software developers and business professionals to understand the requirement to a new systems to document on a existing process. This is an example for sequence diagrams. User and device. Device means system. So user open the application. Second one access the web camera. Third one get the photo, and then fourth one is a photo is automated saved into the device. This is a flow of the diagram. So second example is ATM transactions. So when we are go to the ATM, the user, ATM, and then bank service. The three participate will be there. So first one, user insert the cards and enter the pins, and ATM sends the card details pin to the bank server for the validations, and then bank server is verified to the pin response to the ATM. So ATM promotes user to the enter the amount to withdraw. So users enters the amount. ATM sends to withdraw request to the bank service. Bank service checks the account balance, pauses the transaction. So bank service sends a response to a ATM transaction result. So ATM disperses a cash and updates the account balance. So ATM print the receipt and return the code of the user. This is a sequence diagram. So step to steps they are involved into the process. So they have three involved: user, ATM, and then bank service. They are involved into the three activities into the sequence diagrams. Activity diagram. So EML activity diagram is used to model to workflow or process within a systems. So either the flow of the control within the systems rather than the implementations of the process. It is also termed as a object-oriented flowcharts and applied to the set of the actions and operations applied to the model of the behavior diagrams. The key elements of the activity diagrams involved into the activities, transitions, decision points, start, end, forks, and joins they had used into the activity diagrams. So examples, ATM withdraw money. So that is a first process will start a node. So users insert the card, the activity one. The user enters the pin. So decisions is the pin valid yes or no. So if you means the pin value S means they have proceed to the activity 2. The no means to display the error message and return to the activity 1. So activity 2. So user selects the withdraw a amount. So decisions is the account balance sufficient. So yes, proceed to the activity 3. So if it is means no means the insufficient funds message means it's written to the activity 2. So activity 3. So ATM process the withdraw. So activity 4, ATM dispatch cash and prints the receipt. So activity is a end node. So you user returns the code and cash. This is a overall activity diagram for the examples. This is the examples for the activity diagrams. So request a order. So this is a initial state. So process a order, either requested a order or receive a order. So if you have received a order, the order will be accepted or either order will be rejected. So next one you have to fill the orders. The orders will send the invoice and ship the orders. So the invoice will accept the make a payment and then you have to close a order. So otherwise we will not accept and means they have go to the order rejected and receive a order. This is a flow of the activity diagrams for the make a payment of the processor. So thank you to all.